Hello, Tom from Every Step Calculus, everystepphysics.com. This is a washer method problem. It was on YouTube, and a math person did this by hand, drawing this. Did a good job. But what we're trying to do is pass a test. We don't care about calculus. We don't care about learning about calculus, learning about the washer method. We want to learn about the washer method enough to pass a test. That's it. Okay? Now, the reason you know it's a washer method, okay, is that it has two functions. 1, 2. And it's rotating around something. Okay? The 1 here makes it a hole. In other words, when it rotates around, there's a hole in the middle between 1 and the x-axis. Okay, as you rotate the object around, or the functions around, okay? So remember that. A disk will have one function rotated, so keep that in mind. Also, you'll notice that the first thing here, y equals x squared, that's the first giveaway of what you're dealing with, whether it's an x or a y problem. In other words, dx or dy problem. Dx is with respect to x, and dy would be with integrating with respect to y. So we know that's going to be integrating with respect to x, and then let's do it. I'll talk more about it as we get into it. Index 8 to get my menu. Of course, you buy my program, load them in here. Incidentally, there's a little box down here at the right here, which in every video of mine, you press on it and you can subscribe quick. So press on that and then press subscribe, and subscribe to my site if you can, or if you want to. That helps me. Index 8 to get to my menu. And we're going to scroll down here to washer method. In the everything's alphabetical, so we're going to here's washer method here. When it says busy here, it's loading the program. It takes a little bit to load it the first time, but then it's really fast the subsequent times. And we're going to choose the x-axis, okay, because this is an x squared in the right of the equation here, y equals x squared. And here's the formula. Pi over the range here of a and b, etc. Write that on your paper. Write everything you see on your paper. You look like a genius in your test. Is a number rotated? Yes. It's 1. So we're going to choose that. Press enter. We're going to put alpha 1 for y equals 1. And that looks pretty good. Now I should tell you about a little bit here. There's two functions given. Generally, one is a singular variable, single number. But anyway, we're going to enter the first function here. Okay, so we're going to press alpha and put in x capstan squared. Second one. Now, if you didn't know anything about this, okay, then you would put in y squared. Say, why wouldn't you know anything different about that, okay? But these are the tricks that they like to, as if calculus isn't hard enough, the professors love to trick you with these puzzles. See if you can solve this one, because they're really smart and we're dumb, okay? That's what they're trying to portray. So anyways, so let's put in the wrong one. Alpha y squared. You've entered x equals y squared. You must convert to y equals something, only x's in the answer, okay? So that tells you got to convert this and make a square root of x to it, okay? So I take you back there. You press alpha, second. Here's the square root sign over here and the time sign. And we're going to put in x, and then close off the parentheses. And so I show you the two functions, okay? Now, this is a system. You wouldn't know that from here either. I mean, she mentions it. This is a lady who drew this up here on the blackboard. Obviously pretty smart. And so you're going to 1 minus x squared minus the functions, okay? So I do that for you here. Write this on your paper. Then we solve for, we use those two functions, make them equal to each other, and solve for x. X equals 0 or 1. Now this is the range then. 0 and 1. Okay, so here we got the 0, 1, and here's the two functions in here. Now we're going to square the terms. Remember, to square these you got to use the FOIL method. Remember the FOIL method in algebra? First, outside, inside, and last, you know, when you do these, okay? So I do that for you here. And then we integrate. And of course, integrating is just like this. Write this on your paper. And at x equals 1, you're going to put 1 for every x in the integration function, okay? So we just obtained. See, but you're going to use parentheses around this 1, not quotations. I have to use quotations because I can't do it any other way with the calculator. Calculator does this automatically. So we're going to put quotation marks, 1 to the 5 divided by 5, and 2 times x to the third with 1 to the third, etc. Get the picture? So you write that on your paper because then you want to do the calculations of it. You're going to come up with pi times 11th over 30. You distribute the pi, 11 pi over 30. At 0, x equals 0, you put that in there. Of course, it's going to equal 0. Anybody knows that? And upper minus lower. And the answer is 11 pi over 30, or 0.367 cubic units. Notice the nonsense of this. Notice how small the volume is of this, suppose, of this space in here. Extremely small. Can barely even see it, you know. And yet you're interested in, you know, it has no value. Why would you ever want to know the value of that, you know? I'll guarantee you I'm pretty good at SolidWorks too. I'll guarantee you no calculation for calculus was ever in a SolidWorks problem. SolidWorks is a computer automated drawing system, you know, 3D drawing system. So anyways, go to my site, buy my programs, and pass calculus. Take your book and throw it out. Throw your calculus book away. Throw your study materials away, but never throw this calculator once you got my programs in here away ever, okay? And incidentally, I've loaded, you know, maybe 1,000 programs in here, physics and calculus, and the calculator can take it. It has enough memory for all that. Anyways, go to my site, buy my programs, and pass calculus. Good luck with your classes, huh? Have a good one.